Hello everyone, we are from Group 8 consisting of me, Asri, Tasha and Michael will present our product named as Kavin Lowering Device. So without any further ado, let's just get to the product. But before that, let's see what we are going to discuss for today. The first one is the product overview that consists of the description and also the specifications of the product. And then the second one is the design that consists of the key features and the mechanism. And then the last one is the brief discussion about the result of our static and fatigue analysis. Okay, now we are going to the product overview. This is the preview of our device. For the detailed description about the design, of course, it will be discussed on the design part. So, our device is called Kavin Lowering Device and it is inspired by the innovation from IT Telkom in Surabaya. The device aims to help the burial process using a coffin. However, on the existing product, we found that there are some parts that need to be improved, especially on the operation system that might need too long time in the lowering process. Therefore, we make this product to make the lowering process more efficient. These are the general specifications of the product. The first one is that the material of this device is using a stainless steel 316L. The second one is that the device can hold up to 200 kg. The third one is that in the operation, it needs only two people to operate it. This one is one of improvement of the existing device in which they need like 4 to 5 people to operate their product since there are some parts that need to be knocked down during the lowering process. And then the fourth one is that the handle of the pulley required only around 1.32 kilogram hand force. This value is based on the calculation using gear ratio. So from 100 kilogram, we can reduce it to around 2 kilograms by using the worm gear mechanism. And then the fifth, the dimension is 220 times 125 times 155. This dimension has already been adjusted with the grave and also the ambulance dimension. And then the last one is that we approximate that the operation time of this device start from when the foldable part is removed until the coffin arrives safely on the ground. It needs like 3 minutes only. And then that's all for the general specifications. The other key features of the product will be explained on the next slide.
In this design section, I will explain the crucial features of our tool and also the mechanism. These are the crucial features involved in our tool. The first one is leg. It is inspired by an ambulance stretcher. We made the legs of this tool become foldable because our goal is to put this device in an ambulance. Therefore, for the dimension, we also adjust it with the trunk height of the ambulance car in general. When entering an ambulance, this leg will automatically fold when it hits the car trunk or rear. The second one, we have push handle. We created this part to facilitate the process of moving this tool from one place to another. It can be seen right here that we overlay it with another material to not be slippery at certain times. The third one, we have gearbox. Since the pulley system alone will not be enough to make this heavy device operated by two people, we have added a gear system to simplify the lifting process and reduce the force that the operator must exert. There is a worm gear in this gearbox right here that later on the rope inside can be connected to the upper pulley. We put this gearbox in between of this tool so that it will not add the overall weight of our device. Um, because we have specified the weight based on the condition of the ambulance, which is primary the benchmark in dimensioning. So that's why we put our gearbox inside are between our tool. The fourth one, we have gearbox handle. The purpose of this handle is to simplify the process of turning the gear connected to the pulley. In this handle, we also add another layer of material to avoid slippage. Fifth, we have pulley. This pulley will be connected to the gear system right here below by using a rope. This rope is then attached to the coffin that will be placed right here to help in the lowering of the coffin. The last one, we have modular and foldable coffin base. It is this one. After the coffin is placed on top of the base, right here, is ready to be lowered to the grave, this modular part in the middle must first be removed from the bolts to separate the left and right parts. After it is opened, this base will be folded to not interfere with the coffin lowering process. This is the schematic. When the base is unconnected, the middle modular has a pin that can be removed, and then the base can be folded like this, and like this, and then it can be returned again. And the last one, we have worm gear inside the gearbox. Why do we use worm gear in our systems? It is because based on our analysis, it is difficult to determine a gear ratio that large enough to make this tool work. The most likely to be used is worm gear like this, because it can provide a large ratio that enough to reduce the force exerted. This part is connected to the handle on the outside, and this part is a ratchet that can make the gear stop when the handle is not turning anymore.
So, next we will be discussing about the static analysis of our product. So in our product, there will be two cases. The first case, the coffin will be located at the foldable coffin base, and the second case, the coffin will be lifted up by the pulley.
So next is the static analysis for case 1 when the coffin is located at the foldable coffin base. So after doing analysis, we found that the critical points of the outer surface of the base is located around here when it is in the SFD, and it's around here when it's around the BMD. And then for the critical parts of the inner structure, it will be located at the modular part section. So next is the static analysis at case 2 when the coffin is lifted up by the pulley. So the critical points of the outer surface of the base will be around here at the SFD and around here at the BMD. And then at the critical point at the shaft of the pulley, the critical point is located at the exact pulley.
So next will be the result for case 1. We found that the maximum normal stress for the outer structure is 4.16 megapascal. Its maximum shearing stress is around 0.19 megapascal. And for the inner structure of the base, we found that the maximum normal stress equals to 1.26 megapascal, and its maximum shearing stress equals to 0.25 megapascal. The result for case 2. So for the result for case 2, the maximum normal stress for the outer structure equals to 3.45 megapascal, and its maximum shearing stress is equals to 0.27 megapascal. And for the shaft of the pulley, the maximum normal stress equals to 29.85 megapascal, and its maximum shearing stress equals to 0.75 megapascal. Next, we will be discussing the safety factor and material aspect. So in our product, we will be using the stainless steel 360L. And then if we consider its yield strength with our maximum stress, we found that the safety factor of our product will be around 5.67. The fatigue analysis of our product. So as previously told, the material that will be used is stainless steel 316L. And the Ultimate tensile strength is around 485 megapascal. So the endurance strength is simply half of that, and so the SE will be 242.5 megapascal. And then after some analysis and calculation, we found out that the life expectancy of our product will be N equals to 3.71, and thus concluding that the product has infinite life.